Okay, 10, so I had our request for page 26, number 14. So it says the following three lines intersect to form a triangle. So y equals x plus 1, 2x plus y equals 4, and x plus y equals 5. And you want to find the coordinates of each vertex. So if you think of a triangle, and I'm just going to draw one over here, right? If our three lines connect, right? So I have, say, one line, two lines, and who knows, like three lines. I'm not even drawing them perfectly, right? I just have three lines. So what I want to do is this is my vertex, okay? So I have this vertex, and I have this vertex, and I have this vertex. So when they're talking about the vertexes of a triangle, if this is my triangle, right, they're asking you that point at which they meet. So from our purposes, so I'm just going to highlight the triangle that's formed by the lines, right? So I've just drawn myself a little diagram so I can see what's going on. And so for our purposes, I didn't even draw the actual lines. I just said there was three lines that meet and they form a triangle, and I have three vertices, or one vertex, and one vertex. So obviously I need to find where these two lines meet, and I need to find where these two lines meet, and I need to find where these two lines meet. So it's a pretty long question. All right. So let's start with, let's start with, so I'm just going to read y equals x plus 1 and 2x plus y equals 4. Okay, so this question, right, since we already have y equals x plus 1, this question is best done with substitution. So we'll substitute x plus 1 in here for y. So I'm just going to go ahead and write numbers on these. So 1, 2, and 3, right? And so this is 1 and 2. So I'm finding the intersection of line 1 and line 2. So I'm going to substitute x plus 1 in here. So I'm going to do 2x plus, and instead of writing y, I'm going to write x plus 1, and that equals 4. So now I just need to solve. So I have 2x. So it's like there's a 1 here. We just don't write it. So 1 times x is x, and 1 times 1 is 1. And that equals 4. Then I'm going to add these up. So I collect my like terms. So I have 3x's plus 1 equals 4. And then I'm going to subtract 1 from each side because I want to get rid of this 1 because I'm trying to get x all by itself. So I have 3x equals 3. And then I'm going to divide both sides by 3 because, again, I want to isolate x. And so I have x equals 1. So I've got the x coordinate of the vertex, and now I need to figure out the y coordinate of the vertex. So I'm just going to substitute this back into the easier equation to solve. Well, since this is y equals x plus 1, this one is the one I'm going to use because then I can just do math. So I'm going to do y equals x plus 1. I know that x is 1, so y equals 1 plus 1, and y equals 2. Okay, so therefore I know that one of the coordinates of my vertex is 1, 2. Okay, so that is a vertex. So now let's say, and I don't know which one's which, I don't really care at this point, but I'm just going to say I have one vertex of 1 and 2. All right, now I'm going to go ahead and I've already done 1 and 2. So now I'm going to do 1 and 3. So I have y equals x plus 1. Right, so we've got 1, 2, and 3. Right, so I found where 1 and 2 met. Now I want to find where 1 and 3 meet. So I've got y equals x plus 1 and x plus y equals 5. So this is 1 and this is 3. And so I'm going to go ahead and substitute x plus 1 for y into 3 and solve this one. So I have x plus 1 equals 5. I've got to get rid of my bracket, so I multiply everything by 1. So I have x plus 1 equals 5. So I have 2x, collect my like terms, plus 1 equals 5. Now I want to get rid of the additional 1 on this side, so subtract 1. So 2x equals 4. And then I'm still trying to figure out what x is. So to get rid of this 2, I'm going to divide by 2. And so now I have x equals 2. So I know that the x-coordinate of this vertex is going to be 2, and now I have to figure out the y. So once again, I go up here, and I pick the equation that's the easiest one to do the math on, and it's going to be this one because it's already set up in y equals 4. So I'll do y equals x plus 1, and in this case x is 2, and 2 plus 1 is 3. So this vertex is x is 2 and y is 3. So I'll go put that up here. So now I've got one more vertex left. It's where equation 2 and 3 meet. Okay, so I'm going to go ahead. I like to keep my work looking neat so that you can follow it. So 2 and 3, so we've got 2x plus y equals 4, and we have x plus y equals 5. So if I keep with the substitution method, I can just rearrange one of these, or I can actually use the elimination method and just eliminate my y's, since I already have one y and one y. So I'm going to go ahead and use elimination because it's already set up nicely for elimination. So this is, say, 2 and 3. So in order to get rid of like 1y and 1y, I have to subtract because these are the same signs. So 2x minus 1x is x. Y subtract y is nothing. And 4 subtract 5 is negative 1. So now I know that x is negative 1, and I can go ahead and put it back into one of these equations. So I'm going to pick this one because it again has less math to do. So x plus y equals 5. Negative 1 plus y equals 5. I'm going to add 1 to both sides to get rid of that negative 1. So then I have y equals 6. So now this coordinate pair is negative 1 and 6. So I know that my 3 vertices are, right? So I'm just going to say, therefore, the vertices are at 1, 2, 2, 3, right? xy, xy, and negative 1, 6. So that was part A. And then part B just says, is this a right angle triangle? Explain how you know. So in order for it to be a right angle triangle, our slopes have to be negative reciprocals of each other. Okay? So all I'm going to do right now is I'm going to take my 3 equations. So let me just label this part A and this part B. Okay? And you can rearrange all of the equations to find the slope, right? So let me just write them all down again. I have y equals x plus 1. And that was equation number 1. I have 2x plus y equals 4. Then I have x plus y equals 5. All right, so if I go ahead and take a look at equation number 1, so I'm going to start with that one, right? I have y equals x plus 1. So remember, your slope is always the number in front of your x. So in this case, my slope is 1. So now I'm going to take equation number 2. So equation number 2 is 2x plus y equals 4. So what I want to do with this one is I want to rearrange it to put it into y equals mx plus b form. So that means I'm going to get rid of the 2x on this side, so it's in y equals form. So I have y equals 4 minus 2x. So in this case, I know that my slope is always that number in front of the x. So my slope, which I write with an m, is -2. And then the last question, number 3, so I'm going to grab this one. So I have x plus y equals 5. All right. So again, I want to put this into y equals mx plus b form. So I'm going to subtract my x and subtract my x. And I have y equals 5 minus x. And when I look here, my slope is -1. And if things are negative reciprocals of each other, that means that they multiply. If you take them, they can multiply to -1. So if I do 1 times -2, I get -2. So these two lines aren't at 90-degree angles. If I multiply -2 by -1, I get 2. So those aren't at 90-degree angles. But if I multiply 1 by -1, okay, so I'm kind of running out of paper here, so just give me a second. All right. So if I do 1 times 2, the slopes, right? The slope of 1 times the slope of 2, I get 1 times -2, which equals -2. So that's not at 90-degree angles. Then if I do the slope of 2 times the slope of 3, so the slope of 2 times the slope of 3, that is -2 times -1. That equals +2. So they're not at 90-degree angles. So lastly, I'm going to do the slope of 1 times the slope of 3. So that's 1 times -1, which equals -1. If this happens, and I don't know if you remember this from grade 9 or if you even got here last year with the chaos that was working at home or working at school, anytime if you take the slopes and you multiply them together and you get -1, then you know that those two lines meet at a 90-degree angle. So since the slope of 1 times the slope of 3 is equal to -1, the lines meet at 90 degrees. And therefore it is a right angle triangle, right? So depending on where you got to last year, this one might have been a little bit tougher, but that's how you can tell, all right? You're always looking to see, it's about the slopes. So you're always looking to see if the slopes multiply to -1 to know if a right angle is formed where they meet. So if we go back up here to our triangle, just really quickly, here's line 1 and line 3, and if we had drawn it properly, okay, we would have actually put a 90-degree angle right there. Anyway, 10s, hope that helps.